Hello, Assalamu alaikum everyone. This is Shira Mukhtar and today we are going to get started with our very first topic of AS level maths, and that is series, or in particular the two progressions of AP and GP. So what is AP and what is GP? Let's get started. So first of all, what is AP? AP stands for Arithmetic Progression, or a type of progression where the difference between any two consecutive terms is the same. So let's take this progression as our example: 11, 13, 15, 17, 19, and so on and so forth. So the difference between the first term and the second term is 2. So D equals 2. Similarly, the difference between the second and the third term is 2. And the difference between 15 and 17, it's 2, and similarly 2. And this will continue up till infinity. However, we cannot consider the difference between the first and the third term. As I said earlier, we have to consider the difference between any two consecutive terms. If the difference between any two consecutive terms is the same, then we can consider it an arithmetic progression. So this is what an arithmetic progression is. This progression contains includes two formulas. And what are the formulas? The first formula is for finding out the n term. So a plus n minus 1 into d. So let's say I want to find out, so this is the progression: 11, 13, 15, 17, and 19. Let's say I want to find out the 10th term of this progression. So A denotes the first term. N denotes the value of the nth term, so 10 in this case. And D is the difference, is the common difference, which is 2 in this example. So let's simply plug in the values. 11 is the first term. 11 plus 10 minus 1 into 2. So this gives us, I guess, 29. Yes, 29. So 29 is the 10th term of this progression, of this particular progression. The second formula that we can use is to find out the sum of the n number of terms. So Sn equals to n upon 2, 2 into a plus n minus 1 into d, and bracket close. So let's say I want to find out the sum of 11, 13, 15, 17, and 19. So 1, 2, 3, 4, 5. The sum of these 5 terms. So simply plugging in the values: 2 into 11. So n upon 2 equals to 5 upon 2. 2 into 11. A is the first term. 5 minus 1. And the common difference is 2, giving us 75. So the sum of these 5 terms is 75. So this is it for arithmetic progression. Now let's move on to geometric progression, or GP. So what is a geometric progression? So a geometric progression is simply a type of progression where the ratio between any two consecutive terms is the same. So let's take this sequence or this progression as our example: 24, 12, 6, 3, and so on and so forth. So let's calculate the ratio. How do we calculate the ratio? So we simply divide the second term, which we can denote by T2, and the first term, which we can denote by T1 or A. We simply divide the second term by the first term, which will give us our ratio. So 12 upon 24, sorry, T2 upon T1 equals 12 upon 24 will give us 0.5 or 1/2. Remember, we have to consider consecutive terms. Once again, 6 and 12, let's calculate the ratio between 6 and 12. So T3, because 6 is the third term, upon T2 equals 6 upon 12 equals 0.5 or 1/2. So this clearly shows that this progression follows the trend that a geometric progression would follow, allowing us to conclude that this particular progression is a geometric progression. So once again, all that matters in a geometric progression is the ratio. So the ratio between two consecutive terms. Consecutive terms must be the same. Must be the same. So that is it. That is it for the logic or for the concept of geometric progression. Now, geometric progression includes 4 formulas, and those formulas gives us 3 particular things. So they allow us to calculate 3 particular things. Yeah, so 4 formulas allowing us to calculate 3 particular things. And how's that? Let's see. So formula, the first one is for finding out the nth term. So AR n minus 1. So 24, 12, 6, and 3. So let's once again consider this progression for our examples. Let's say I want to calculate the 5th term of this progression. So simply substituting 24 in A, which is once again the first term, and R is the ratio, R equals ratio, N is the value of the nth term. Nth term. So 24 into 0.5, we already calculated the ratio, and 5 minus 1, which is going to give us, let's see, what is it? 1.5. So the 5th term of this progression is 1.5. Yeah, and you can even see calculated by seeing the trend. So 24, 12, 6, 3, 1.5, and then further on. Now if I want to calculate the sum, let's say, so the formula for the sum is A 1 minus R n 1 minus R. So where R is less than 1. So if I want to calculate the sum of 5 terms, simply substituting the values, 1 minus 0.5 to the power 5 upon 1 minus 0.5. So this is going to give us, let's see, 1 minus 0. 46.5. So the sum of the first 5 terms is going to give us 46.5 as our answer. Similarly, we have another formula which we can use to calculate the sum. So what is that formula? Let's see. So this is the third formula. Sum equals A R n minus 1 upon R minus 1, where R is greater than 1. So let's say if the ratio is 1.5 or 2, 3, so we are going to use this particular formula. Well, the second formula was used for ratios less than 1. So let me write it down here. 1 minus r to the n upon 1 minus r, where r is less than 1. Finally, we have the fourth formula, and that is the sum to infinity. So what is the sum to infinity? So this is simply the formula. Now the sum to infinity, the concept is quite interesting, and let's talk about the concept. So yep, let me erase the entire thing. So first of all, we'll have to understand the difference between convergent and divergent. Convergent series and divergent. Series. Now convergent series are those series whose ratio lies between this boundary, while divergent series are those series whose ratio does not lie in this particular boundary. So the ratio does not lie between -1 and 1 and +1. Between -1 and +1. So for example, 1 upon 2 plus 1 upon 4 plus 1 upon 8 plus 1 upon 16, so on and so forth. So this particular series is going to give us a finite constant. So if we keep adding this particular series, this one, eventually we'll reach to a constant, to a, that is somewhat a constant, maybe to 2.00, something like this. But eventually we will reach to a particular constant. However, in such series, so 1 plus x squared plus x cubed plus x4, so whatever you put here, we are never ever going to reach a constant limit. We are only going to read we are never going to reach anything. So it will tend to infinity. It will move on and will go on forever. However, this series, so 1 upon 2 plus 1 upon 4, so if we find out the ratio, so 1 upon 4 divided by 1 upon 2, this is going to give us 1/2. So 1/2 tells us that this particular series is a convergent series, and this is eventually going to lead to a finite limit. So we can find the sum to infinity of this particular series. So how do we do that? A upon 1 minus r equals 1, let's use 0.5 upon 1 minus, this was the ratio, 1 minus 0.5, which is going to give us 1. So if we keep adding on the this particular series, eventually will lead to a number that is close to 1. So not approximately 1, and it won't be a whole number, but it will be very, very close to the number 1. So we'll round it off to the next whole number. However, we cannot reach to a constant limit with this series. You can try it out. You will never reach to a constant limit. So this is the concept of sum to infinity, and this is how we use sum to infinity in our calculations. So let's say let's use the sum to infinity for this series, 24, 12, 6, and 3. So as sum to infinity, 24, so a upon 1 minus r, sum to infinity equals 24 upon 1 minus 0.5. So 12 divided by 24, will give us 1 minus 0.5. 0.5 is the ratio. Let's see what is it going to give us. It's going to give us 48. So 48 is the sum to infinity. So eventually, if we keep adding on the series, eventually will lead to a number that is approximately 48. And that is it for geometric progression. I hope you found my lecture helpful, and I hope it assisted you in some way or the other. And if you have any questions, please drop down your question in the comment box or in the comment section. And yeah, that is it for today. Thank you for tuning in, and goodbye.